Okay, so our first step is going to be to open up the file that was given for chapter number 1. Yeah. So let's unzip that particular file. You should have downloaded, and we'll open that file up. We'll say, okay, it's coming in meters. That's fine. You should see a smiley face, or frowning face, rather. It's our job to kind of do this. Now, I've opened Grasshopper here just to get us ready. But before we get too crazy with scripting and getting distracted, let's keep in mind our whole point is to, for version 2 of the algorithm, just appreciate what's been given. Now, we can use Grasshopper to do that, but because we're all supposed to be beginners here, let's just hide that for now and ask the question, if you actually wanted to know more information about what data has been given to you here, just using traditional CAD methods, what would you do? And in general, all CAD software, not just Rhino, allows you to sort of maybe click something and go investigate the properties. Yeah. And in that case right here, you see right here, there's a properties window. It tells you a little bit about it. You can click details, and it'll give you even more information about it. And this is really important because if you look at this picture, you're now starting to get if you look at this picture, you say it's a face, a frowning face, if you were being more specific. If you were using Italian, you'd say faccia. That means face in Italian. If you were in China, mainland China, you might say lian. That means face in Chinese. It doesn't really matter what human language you're using. We'd all come to the same consensus of what this is. None of us would say this is something with ID 0305F424. You know, that's not how we think. But if we want to get the computer to start doing stuff for us and all the benefits that come with that, we need to have empathy with what the computer sees. And in this situation, the computer doesn't say face, faccia, lian. It says this stuff. So in order for us to start speaking the computer's language, we need to really start to understand what we've been given. In this situation, we've been given a piece of geometry for the eye, which is a circle. And let's just double check to see if we have the same thing for the other eye, right? So it looks like the other eye is the exact same situation. So it's in different information. The key is they're circles, and they have certain properties that make them circles. The outer portion of the face, again, I can open it up again and see that it's a piece of geometry. No surprise, it's a CAD piece of software. It's good at that stuff. And finally, what's the mouth? The mouth is an arc, again. So we have now just learned how to inform the next part of our algorithm. The next part of our algorithm is going to need to have this information handy, because if we don't appreciate how this works for the computer in terms of what he sees, then we'll never be able to instruct the computer with any degree of accuracy how to do what we want him to do. So this is really important going forward. That's why chapter 1's called What Does the Computer See? Is because if you do not understand the types of objects that you've been given, you can't just say you have been given a DWG file with a smiley face, or frowning face in it rather. You need to start speaking the computer's language, and much of that comes down to the understanding of what objects are. And in this situation, you've been given a bunch of geometrical objects. If we want to be specific, there are geometrical objects which were programmatically defined by a company called McNeil & Associates. But for right now, the computer just sees a structure of data. All of them are geometry objects. Some of the geometrical types are arcs. Some of them are circles. But all of them relate back to things that you should know from your engineering studies or architectural studies, which is geometry. So that's the way the data is structured. Now knowing this, we can go back to paper and finish our algorithm on paper before heading to Grasshopper.